So first, to calculate the magnitude, we have 4 pi times 10 to the minus 7 times the current, 20, divided by 2 pi times the distance, 0.2. And so that is 2 times 10 to the minus 7 times 20 over 0.2. That is so that is 200 times 10 to the minus 7. So 2 times 10 to the minus 5. And now for the direction, the right-hand rule says that those field lines are going clockwise. And so at a point down at this part of the circle, a tangent is going this way. What? Just draw the vector. So the magnetic field vector is 2.0 times 10 to the minus 5th Tesla, pointing this direction. Any questions? All right, so now we can move on to the second application of the right-hand rule in calculating magnetic fields produced by a coil of wire. So magnetic field vectors produced by a coil of wire again, we need a magnitude and a direction, and again, the magnitude is going to come from Ampere's law. We're going to use sort of the second version of that. And that says that the magnitude of the magnetic field vector is equal to mu sub 0, so that's the same one we used before, times the current I times n, I'll tell you what all these stand for in a second, divided by a length L. And so let me draw an example coil. So mu sub 0 is the same thing it was before, 4 pi times 10 to the minus 7 Tesla meters per ampere. N is the number of loops. So in this case, N would be 1, 2, 3, 4, 5, 6. And the length L, this is one you need to make a mental note of. We're not talking about the length of length of wire that's wrapped up in that loop. We're just talking about the amount of space it takes up in this dimension, okay? So you could, I mean, if you wrap a thin wire really tightly, you could maybe have, you know, hundreds of loops of wire only take up a centimeter, you know. The real length of the wire is meters, but the L value is just a centimeter. Also, don't get this L confused with the diameter of that coil. That's going to come up in later calculations, but that doesn't matter to us right now. No, it should be in meters. So for the direction, we're going to use the second application of the right-hand rule. The B vectors always point directly down the center of the coil. The question is just which direction. So down the center of the coil. Think of it as like through the tube. Wrap your fingers in the direction current travels around the coil. And once you do that, your thumb is in the direction of the magnetic field vector. Okay, so let's do two examples for that direction. Okay, so let's say the current is going this way. What direction around those circular loops is the current going? So if it's going out this side, it's going in this side, and that means your fingers have to curl like up the front, in the page, down the back, out the bottom, right? And so what direction is the magnetic field vector? Yeah, that way. So that means that the magnetic field vector is that way. Now what if you took the same thing and just change the direction. So now it's going this way and coming out this way. Now what direction is the magnetic field vector? So now, yeah, it's going up the back, out there, down the front, so this way, and so the magnetic field vector is to the other wall. Any questions about that? Okay, let's stop there, and we'll do some example problems next time. Mm-hmm. Oh, it does? That's good. The last one, the circuits?
No, I mean like from the last test, like this is way.
Oh yeah, yeah,
way better.
those electric fields.
Are we gonna have a makeup test day, or is it not time for that?
Yeah, we do. It's on the syllabus. I think you should look on the syllabus, but I think it's the last Thursday of class.
Is there like no actual class? It's just like makeup test?
Right. It's just like a test day. And if you don't want to do a makeup test, you just don't have to come.
If we do worse on the makeup.
I'll keep your better score.
I don't plan on that happening.
Yeah, right.
So it's always with you.
Are we still gonna have 2 more tests before the final?
Yep.
Okay.
I mean, well, no, I mean, we have one more test and then the makeup test.
Oh.
So we're not gonna hit all the material potentially, is that correct?
I think, yeah, we might not get to optics. We'll get to everything else, though. Optics is stupid. Yeah. Well, we don't even, I don't know, we don't even talk about that. We just talk about, like, geometric optics. So, like, it talks about, like, how lenses work and stuff. That's kind of interesting, but I don't know, this stuff is better. This is the important stuff. That's just sort of icing on the cake. Sure.
Grab it
When will Tuesday's lecture be?
I guess I'll put that up at 2 o'clock today.
Okay.
on. I said I wish I had a brain because I had a question.